Hello, class. Been a while since I made a video. This is the first time in a week now that I've been able to get out of the house. So yeah, I still have icy roads in my neighborhood, uh, so I had to risk that to come to make your videos. Plus, I haven't had any fast food for a week, so I'm craving a little bit. But and by the way, if you're watching this video sometime other than spring of 2026, this is late January when we've just missed a full week of school because of all the ice and snow. I don't know about where the rest of you live, but in my neighborhood, like Saturday, we got, I don't know, like an inch maybe of sleet on top of all the snow. So my roads have been nothing but ice since then. I kind of live out in the boondocks where they don't get plowed. So just wait until the sun can thaw everything out. And there's a lot of trees that are on my road. So yeah, I'm getting a little cabin fever. Yes. All right. So to fix my cabin fever, I'm now at the office making math videos. All right. So the topic for today is section 1.2 and 1.3, solving quadratic equations. Now, the reason I'm doing those together, I don't know why the book split them apart. The book in 1.2, all their quadratic equations have real solutions. And then in 1.3, they do complex numbers, and then they do complex quadratic equations with complex answers. We've already did complex numbers, and so now what we can do is do all our quadratic equations at once. Doesn't matter, the process to solving them does not matter if they're real or imaginary. It's just the only difference is at the end. If it's imaginary, we need the I in the answer. And then later in the semester, we're doing some other stuff. We'll talk about how that impacts like things like x-intercepts and such. But for solving quadratic equations, the process is exactly the same regardless of what the answer turns out to be. Okay. All right. And I don't know how long this video will go. I may have to split it into two parts. We'll just see how it goes. So let's take a little bit closer look at what we'll be doing today. Here. Now, as I was getting prepped for the video today, I noticed that for some reason I left off solve by factoring. And I think it's when I was redoing my notes, the old book and the new book, some of the difference I talked about, like where they do complex numbers. Somehow I left those out of the notes. I've now added a page in Blackboard that has the solve by factoring examples. But yeah, there are three techniques we're going to talk about with solving quadratic equations. Oh, by the way, quadratic equation, the basic quadratic equation, that means it's a degree 2 polynomial. And so we're going to be solving ax squared plus bx plus c equals 0 or some variation of that. So one of the core ideas in an algebra course sequence or sequence course is we're always learning how to solve more and more types of equations. So in 1.1, we focused on linear equations. Then we did some proportions and some equations with fractions. And they got kind of messy. Those were all degree 1 equations. All right, so quadratic equations are degree 2. And so they have different solving techniques. And that's one of the things that you have to be able to do as a college algebra student is when you're faced with an equation, one, recognize what type of equation it is. And then two, what techniques do you use to use it? Because linear equations, when you're solving for x, you just get all your x's or all your variables on one side, constants on the other. You isolate the variable, you're done. Can't do that with quadratic equations. Not exactly. So that's and all semester we're going to be solving linear and quadratic equations all the time. So you just got to be flexible with going back and forth between the two. So that is today's video is section 1, 2, and 1, 3. All right, so let's see. So I mentioned that I put this missing page in Blackboard. And I apologize for the kind of handwritten part of the notes. I need my laptop to fix a PDF. And of course, I left my laptop at home. So let me show you where it is. All right, so if you're following along with the printouts for today's lecture, We're going to start. There is a one-page solved by factoring, and then the 1, 2, and 1, 3, the quadratic equations. That is the square root property and the quadratic formula. So we'll be using both of these files today. Which one do I want to start with? Before we get started on the actual solving, I do want, as a warm-up exercise, to do some simplification with radicals. Since we are solving square roots, we're often going to get radicals as an answer. And so this is sort of a carryover from the R8 homework, the roots and radicals. So hopefully you've done that. And so this will be just a little bit of review, but it's important review. And so if you look at number 1 and 2 here, so what these are is like, let's say that you were solving a quadratic equation with a quadratic formula. This is a very typical looking answer. Right. And so a lot of the problems that we're going to have with quadratic formula is not really algebra level stuff. It's actually arithmetic level stuff on how do you simplify correctly something like this. So let's start with number 1. Because we have 10 plus or minus square root of 50 over 5. So now the question is, how do you simplify that? What you absolutely don't want to do is do 50 divided by 5, because you cannot divide something inside the radical with something outside. Just like for multiplying, outside stays with outside, inside stays with inside. So that's part of a very common mistake. We can't treat those, we can't simplify those because of the radical. You also cannot simplify the 10 and the 5 because this plus or minus makes that top a binomial. And so when you have a binomial, you can either simplify both parts or nothing. It's all or nothing. It's not one or the other. So let me show you a couple ways to look at this. So first of all, when you have that square root of 50, is that simplified? So anytime you have these square roots, go in there, make sure they're simplified. And for those of you that only have graphing calculators, graph calculator is going to give you a decimal answer here. You're going to have to go in and do those by hand. Let me get the answer, and then I'll back up and talk about doing it by hand. The square root of 50 is 5 square root of 2. Once we simplify that radical, we have 10 plus or minus 5 square root of 2 over 5. Now, where did that square root of 50 come from? Again, ideally, this is something that I would like everybody to be able to do without a calculator, but we have a lot of stuff to go over. So this is one place where, like, if you have a scientific calculator, that goes straight to 5 square root of 2. But where did that come from? Well, if you're simplifying numbers or square roots by hand without a calculator, because if your calculator is giving you a decimal, this is where you have to do your factor trees and the grouping method. So if you look at the factor tree for 50, that's what 5 times 10, and then 10 is 2 times 5. So those are all prime numbers. So what we do with that is square root of 50 is 1, 2, and 2 5s. How does that help us? Well, we've talked about this with R8, like doing the grouping method. We did a little bit more with variables, not so much with numbers. But the grouping method says, since we're doing with a square root, any pair you have, you're going to pull one out. Or if it helps, that's 5 times 5 is 25. So what's the square root of 25? It is 5. So that pair of 5s is pull 1 5 out. That 2 does not pair up with anything. It's left over, so it stays inside the radical. So that's a review of R8. One of the reasons we did that section is so that you could simplify square roots that are not perfect squares. Okay, now look at this. And so can we just do the 5 divided by 5? No, just for the same reason we can't do the 10 divided by 5. So there's 2 ways to do this. For the R7 homework, the rational expressions, officially that's extra credit now because my in-person classes, they got behind because of all the weather. So for the online classes, I made it extra credit. But since about half of you did it, that what we do up here with this binomial is we can factor out the GCF of 5. 2 plus or minus square root of 2 over 5. Then, since that's a factor, you can divide out the 5s. That would be 2 plus or minus square root of 2. Right, so this is, like that, this is a typical answer you're going to get with the quadratic formula. So to simplify this one, once you get to this point, make sure you simplify your radical. And then once you simplify your radical, is there a GCF in all three? If there is, you divide all three of them. So we're dividing that by 5, that by 5, that by 5. This is why we can do it, but a lot of times I think students don't want to write, factor out the GCF. Just look for the GCF up here. They're all divisible by 5, so divide them all by 5. Again, don't do anything inside the radical, just outside the radical. Okay. And if this was the answer, unless they've updated anything, which I don't think they have, MATLAB doesn't have a plus or minus key, so you would actually have to enter that as 2 plus square root of 2, comma 2 minus square root of 2. And when in doubt, look at the example, look at their answer, but I'm pretty sure that they still don't have the plus or minus button. And so you do have to write it twice. One with plus, one with minus. All right. I'm out of room here, but let's do number 2 as well. Again, we're going to see answers like this when we get to the quadratic formula. So we're doing a little bit of review before we jump into the actual solving process. All right, so we have 3 plus or minus square root of negative 36 over 6. Okay, so simplify the radical. That's step 1. So what is the square root of negative 36? Well, because of the square root of a negative, we know I is going to be involved, and then what's the square root of 36? That's where you can go, if you're not for sure, you can go to your calculator, but that is, 6. And so because of the square root of negative 1, we get 6i. All right. Now there's 2 ways, like if you have a radical, it doesn't do you any good to, like here when we're trying to simplify this, if you have a radical left over, it doesn't do you much good to split up the plus or minus in the simplifying process. If it's a whole number or an I, we could, if it's a whole number, you definitely, like if that was just 3 plus or minus 6 over 6, I would expect you to do 3 plus 6 over 6 is one answer, and 3 minus 6 over 6 is one answer. With that I still tend to, is there a GCF in all three? Well, 3, 6, and 6 can all be divided by 3. So divide each one of these by 3. So that would be 1 plus or minus 2i over 2. Again, without MATLAB having that plus or minus key, that would be 1 plus 2i over 2, comma 1 minus 2i over 2. Now, an alternate way to do that, and I'm fine with either one. This is like the more likely way. The other way you could do this is when you have that binomial divided by a single term, you can split it up and say 3 over 6 plus or minus 6i over 6. Because what that 6 is, it's dividing both of those. So you could split it up into 2 separate fractions. Just we're not used to doing that with the plus or minus, but it still works out the same. And then 3 6 is 1/2 plus or minus 6i over 6 is I. Those are equivalent answers. Or you could do 1/2 plus I and then 1/2 minus I. That would be equivalent to those 2 answers. Like I said, I'm good with either way. Sometimes people who code MATLAB don't like equivalent answers. I would expect that this would be perfectly fine, but that you really want to watch out. If they say put the answer in the a plus bi form, then that's what they want. But this is probably more in 1.3 when did complex numbers by themselves. If we're just solving quadratic equations, then this is probably going to be perfectly fine. All right. So this is again, this is a warm up because when we're solving quadratic equations and using the quadratic formula, we're going to get answers that look like this all the time. And I think like the number one reason students get wrong answers to the quadratic formula is this simplifying process. So we're going to come back in this, but kind of wanted to get our toe dipped in the water a little bit before we saw this, just so it's in the back of your brain. All right. So let's get on to solving. Now, this handout, the 1, 2, 1, 3, starts with the square root property. That's normally the second one I cover. Like I said, for some reason, when I was redoing my notes, I left off the page was solved by factoring. I think I originally had it in 1.1, and then when I moved it over, it just got lost in the translation. All right, but when we're solving quadratic equations, keep in the back of your brain that the generic quadratic equation that we're solving is ax squared plus bx plus c equals 0. So it's a degree 2. Most of them are going to have, an x squared and an x and a constant. Make sure that you're putting in descending order. All right, so the question is, how do you solve this? Well, for solving linear equations, you might want to isolate x. But if you did that, you're going to have an x squared over here. And so you can't solve something that has x's and x squareds by normal linear equation methods. So as we're going through these quadratic equations, these degree 2, we're going to have 3 techniques that we're going to talk about. Okay. The first one is solve by factoring. The second one is going to be using the square root property. And then the third one is going to be the quadratic form, which I don't have that. We'll get to that. So the 3 techniques are solve by factoring, solve by square root property, solve by quadratic form. The quadratic formula, that's sort of like the catch-all. You can solve any quadratic equation with the quadratic formula, but it's not always the most efficient way to do it. Right? But when in doubt, you can always go to the quadratic formula. The solving by factoring, if you can factor it, then it tends to be a lot quicker, but that's a big if, right? It sort of depends on how comfortable you are with your factoring skills, and there's no guarantee that these are going to factor. Like the earlier ones might, but like the later ones, there's no guarantee, especially if we get into complex solutions. And so my recommendation, this as a teacher and a student, is when you get a quadratic equation to solve, see if it can factor. First of all, you got to make sure it's equal to 0 because we can't factor it unless it's all on the same side. But if you can factor it, then you're probably going to save yourself some time. But if you look at it for a bit and you don't see how to factor it, then I would say go to the quadratic formula or possibly the square root property, which we'll talk about that as well. But if you can't see how to factor it, then this method doesn't work because one, it may be complex factoring, or 2, it may not factor at all. So what are the steps when we're solving by factoring? 1, set the equation equal to 0. So that is very different than solving linear equations where we're trying to get variables on one side, constant on the other. Solving by factoring has to be equal to 0 before we do anything else. Step 2, well, that's where it gets its name. We're going to factor. Okay? So all your factoring techniques are fair game. We tried to make it so that they're not quite as messy as some of the homework in the factoring homework, but you're going to do trinomials, you're going to do difference of squares, you're going to do GCFs. Theoretically, you could do factor by grouping, but I don't know if we put any of those in there. But whatever it takes to factor it. And now, how does that help us? Well, the next step is set each factor equal to 0 and solve. And where this comes from is something we'll call the zero product property. That is, if A times B equals 0, what can you tell me about A or B? at least one of those must equal 0. There's no way you can multiply two real numbers and get 0 as a product if at least one of them isn't 0. Could be that they're both 0, but at least one of them has to be 0. And this only works if it's 0. If I said this was equal to 1, there's a lot of different numbers I could multiply by each other to get one that are not 1, like 1/2 and 2, 1/3 and 3. You get the idea, right? So this only works if it equals 0. That's why step 1, when we're solving equations by factoring, is set it equals 0, that we can do this. And what we're doing is once we factor it, we're going to get either binomials or like a monomial if it's a GCF. And those are going to be linear, no longer degree 2, they're going to be degree 1. And we can solve degree 1 equations because that's linear equations. So how does this work? We'll come back and mention solve by squares. Okay, so look at number 16. We have x squared minus 4 equal to 0. All right, so let's solve this by factor. So step 1, set it equal to 0. So that's done. So if you haven't done this in a while, you may want to like go through and use this like as a checklist. All right, so step 1 is done because it's equal to 0. What's step 2? Step 2 is factor. And so how do we factor this? Well, you have to recognize this is a binomial and it's a difference, and it is a difference of squares. So this is a difference of squares. How do you factor x squared minus 4? Well, x times x is x squared. 2 times 2 gives you the 4. You get the minus 4, you got the plus or minus. Okay, so then it's equal to 0. If you need more room to do your factoring, don't do your my recommendation is don't do your factoring right below your equation. Like go off to the side, do your factoring off the side, and then once you get your factoring answer, put it back in here, right? And if you're a little iffy on your factoring, by all means, float it back out just to check and make sure you got the right factoring before you do the solving. That gives me x squared minus 2x plus 2x, so those cancel, and then minus 4. So that is step 2, is factor. What is step 3? So step 3 is set each factor equal to 0 and solve. So we have x plus 2 equal to 0, and these are totally separate problems, and x minus 2 equal to 0. These are linear equations. These are straightforward solving. Get x equals -2, x equals +2. And yes, we do expect 2 answers. When you're solving any polynomial equation, the degree tells you like the maximum number of answers. So since we're solving a quadratic equation with degree 2, we generally are going to have 2 answers. Now it could be repeated, like it could have been a 2 and 2 if the factors would have been the same. We only got technically 1 answer. But if we're doing quadratic equations, the majority of the time we're going to get 2 answers. All right. Relatively straightforward. So the solve by factoring, it's the factoring part that can get messy. So let's do 17. So we have 4x squared minus 20 equal to 0. Okay, so step 1 is done. It's equal to 0. So what about step 2? How do you factor this? Well, it's not a trinomial, so we don't have to worry about reversible AC method. It's not 4 terms, so it's not factored by grouping. Is it a difference of squares? Well, it is a binomial with x squared, but 4 and 20 are not squared. So what that tells me, that's a GCF. And there's a GCF of 4 in both of those. Divide both of those by 4. We get x squared minus 5. All right. Now, what you have to do is you always have to ask yourself if that's when that's x squared, can this factor again? Is this factorable? Well, is that a difference of squares? Right, which is kind of really the only choice, right? Because we went through that. Well, 5 is not a perfect square. So with our basic techniques, no. No. Well, this is one reason why the square roots were mentioned earlier. And so this is a square root problem. So do I want to, I didn't mean to do this yet. I was going to save this problem. Um, but well, since we're here, I can come back to it later, but what we're doing is, we get 4 equal to 0, and we get x squared minus 5 equal to 0. Over here, this is a false statement. So we just toss it. If one of your factors doesn't have an x, if it's just a constant, then we can ignore it because we only want x's. Yeah. All right. So how do we solve x squared minus 5 equal to 0? Well, since it doesn't factor, what else might we try? So you're already ahead of me on this. Well, what happens if we add 5 to both sides? Well, we're trying to solve for x. So how can we go from x squared to x? Well, what's the opposite of squaring something? The opposite of squaring something is taking the square root. Now, the reason we do this is x squared and x are opposite operations, or sorry, square root and squared are opposite operations, so they cancel out. That's the whole reason we're doing this. Here's where you have to be careful though with the square root property, is anytime you take the square root of both sides, at least one of those sides, you need to do plus or minus. Technically, you can do it on both, but that it's messy and we don't really need to. So here is the most common mistake with square root property is don't forget your plus or minus. Okay, so we have two answers here. We have the square root of 5 and negative square root of 5. Which in a way, it's sort of, I asked if this is a difference of squares, not whole number, but if you think about it, square root of 5 times square root of 5 is square root of 25, which is 5. So the different squares are technically would work. We're just not used to thinking about it. So I jumped ahead a little bit of square root property. I apologize, but where we use the square root property, and I'm going to do more examples of this after we do just pure factoring, is if you have an x squared and a constant with no x, then you can follow this. Now, so the square root property is a bit different because now we're getting x squared by itself. Just like if we normally solve for x, we can get x squared by itself. That would not work if there was still an x over here. This only works if there's a squared term and a constant, or it gets messy on that, but you'll see what I'm talking about. All right. So this is why when you're solving equations, we need factoring techniques, we need square root property techniques, and we need quadratic formula. All right. So apologize for jumping that in the middle of the factoring section. I didn't look at the example close enough before I wrote it down. So we're going to come back to this if it's not making sense. So put a pin in it, come back. Okay, so let's do some more just factoring. Right. How about this one? We're going to solve x minus 3 times x plus 7 equals 0. All right, so what is your first instinct? Well, if you're thinking FOIL, it's kind of what I was expecting because students, we tend to like to FOIL, because it's once you get in that habit, it's, that's quick to do. Here's the problem. If you're foiling is the opposite of factoring. So do not FOIL. This is equal to zero, right? And if we were going to get like calculus, pre-calculus level stuff, we'd make these not equal to zero, and then that's a whole nother level. But it's already equal to zero, so step one is done. What is step two? Step two is factor. Is this factor? Hopefully you're saying yes, because isn't that something times something? So if you're foiling, you're undoing the factoring because it's already something times something. So now all you have to do is this is x minus 3 equal to 0, x plus 7 equal to 0. So we get two answers. Now add 3 to both sides, so we get x equals 3. Subtract 7 from both sides, so we get 3 and negative 7. So if you're solving by factoring, do these 3 steps for every single problem, whether you need them or not, because that kind of helps you set up the process. Yeah. So how about 19? And x times 16x plus 4 equal to 0. So we're going to solve that. Step 1, well, that's equal to 0, so that's done. Step 2 is this factor. Yes, because it's something times something. Okay, so step 3. So what is step 3? Step 3, set each factor equal to 0 and solve. Okay, so what does that look like? So here's what I say a lot of people do is all they would do is 16x plus 4 is equal to 0. They'd solve that and call it good. If you do that, you're going to get a wrong answer. Reason being, this is not the only factor. And I might have mentioned once or twice, I really wish we would be in the habit of putting GCFs in parentheses, because now if I put it in parentheses, I think it makes it a little bit easier to see that that is a factor. So it's not just a binomial factor, it could be a GCF factor as well. You take that x, set that x equals 0 as well. So right there, there's one of your answers. Or if that was like 3x, then you would divide both sides by 3, 0 divided by 3 is still 0. So if you have an x factor right here out front that's not a binomial, you're going to get 0 as an answer. This other one, we just solve as normal. Fraction with this. So we're subtracting 4 from both sides and dividing by 16. And don't forget to simplify your fractions. So negative 4/16 is negative 1/4. All right. So when it comes to solving by factoring, if it's already equal to 0, already factored, most of the work is done for you. So let's jump to number 22. So we have x squared minus 8x plus minus 9 equal to 0. Solving that. Step 1, 0, which is good. Step 2, we need a factor, which it's not because it's not something times something. So this is where you got to know what technique you're going to use. It's a trinomial. So you can use the reverse FOIL or AC method. I'm going to use the reverse FOIL because when there's a 1 in front of it, to me, that makes it a little bit less messy. And I'm going to kind of speed through the factoring a little bit here because we're really focusing on the solving part. But when I did reverse factoring, remember, this is and what we're doing. And so to get the x squared, we know we need x and x. What do the signs have to be? Well, to get a -9, we need a plus and a minus. So now which pair is going to multiply to give me 8? Sorry, to multiply to give me 9. It's going to, in this case, subtract to give me 8. The 9 and the 1. Which one needs to be positive or negative? Well, it's a -8, so we need a -9 plus 1. And again, if you need to go off the side and do all this, you need to FOIL it out to check, do that, but I would not do your factoring like right on top of it unless you're very comfortable with it. But do check it because that's plus 1x minus 9x, which is minus 8x, and that is minus 9. All right. So so again, the solving by factoring, this is the by factoring part is where this can get messy. But once you factor it, then we're back to basic linear equations. This is -1 and x equals 9, which would be separated by commas in the math. All right, so what is missing? Yeah, really need to update these notes. So far we did everything equal to 0. See if I can get one from the homework. Yep. So here's a messy one from the homework. So what we can do with it. So this is my number 5 from the home. The 1.2, 1.3. So we're solving 25x squared plus 49 equals 70x. We're going to solve by factor. All right, so what is the first step? Anytime you're solving by factoring, we're getting it now. Step 1 has to be equal to 0. This is not equal to 0. So we have something to do on step 1. Fine. So the question is, which side do you take everything to? It doesn't really matter in the long run, but when we're factoring, we'd like our leading coefficient to be positive. So what I do is I take everything to whatever side makes that square term positive. Okay, so I've got a positive 25x over here, so I'm going to leave these on this side, and I'm going to move the 70x over. So to zero it out over here, we're going to subtract 70x. Now, where do we subtract 70x over here? Well, one, there's no, keep track of your like terms. There is no x over here, so there's no like terms. And we want it in descending order. So we want that 70x in the middle. So that way we have our 25x squared minus 70x plus 49 is equal to 0. So it's in descending order, and the leading coefficient is positive. All right. So now, how do we factor this? We'll always look for a GCF. The 25 and the 70 both have an x and a 5, but the 49 is 7 times 7. Which 7 goes into 70, but it doesn't go to 25, so there's no GCF. So this means it's just a trinomial. So it's either reverse FOIL or AC method. Now, for most people, when there's big numbers in here, you're probably going to go AC method, which is fine. Again, since I am kind of minimizing the factoring and kind of focusing on the solving right now, I'm going to do the reverse FOIL because this one's not as bad as it might look. And again, the reason I can say that is because I've been factoring for a long time. Factoring, if you don't see this, then, well, first of all, if the factoring part here really throws you off, what did I say is your backup? Right? You can always do quadratic formula, like once we talk about it, right? So even though it might say solve by factoring in the instructions, if you get here and get stuck on the factoring, do the quadratic formula. We'll get to it in a bit. So what I'm going to do is I'm going to start with those two. So we get 5x, 5x, that gives me 25. What do the signs have to be? Well, to get a plus 49, they need to be the same. If we're doing positive times positive, negative times negative. That negative tells me they're both negative. And then how do I get 49? Well, let's use the 7 and 7. Does that work? Yes, because we got minus 35x and minus 35x gives us the minus 70x. So again, this is where I'm kind of speeding through that part of it because technically we've already covered that. That's why we did the R5 one. All right. So now we factored it. So step 2 is done. Step 3 is take each factor, set it equal to 0. So 5x minus 7 equals 0, 5x minus 7 equals 0. Solve them as normal. Now, something slightly different happens here. Once we get down to the end, we get the same answer. So we do occasionally, this is what I call a repeated solution. So if you get a repeated solution, only put 1 in MATLAB. You put it twice, they might have changed it, but last time I checked, if you put it twice, the MATLAB would count it wrong. If you did that on the test and put both of them, I'd give you full credit. But it's sort of like in a final answer, we don't put 1x, we just put x, or we don't put like if we had 3x at the first power, we wouldn't put the 1 exponent, we just put 3. So if you got repeated solutions, only put 1 of them. Yeah, that's the preferred way. It's only put once or only put 1 in MATLAB. Right, so this is the kind of the messy solved by factoring. Okay. Because that's a trinomial with a big numbers, and so it got kind of lucky with the reverse FOIL method. AC method, you'd be doing 25 times 49, looking for all the factors, but eventually you'd get here. But this is something that we could do by factoring, but factoring, like I said, factoring is not always the most efficient. As long as you can see how to factor, like on this one, that x squared minus 8x minus 9 was not too bad to factor. The x squared minus 4 is a difference of squares. That's not too bad to factor. All right. That's sort of the power of the solve by factoring. If you can see how to factor it, it's usually going to be quicker. All right, so that's the first method. So when you're always check, sort of like when we tell you to factor, always look for GCF first. When you're solving quadratic equations, always look for to see if you can factor it first. Right, so let's talk about the square root property. Okay, so I'm back to the 1, 2. It's just in this thing. Sorry, this is the notes in the new handout that I put. No, actually, I think it's written out a little better than the 1, 2, 1, 3. All right. So now we get into 1, 2, 3, and 1, 2, and 1, 3 handout. So solving by square root property. So what we're looking for is a squared term and a constant, but no x, or like a y squared and a constant with no y, and so on. There are some other versions of that, and I'll show you, but those are the main ones we're going to do. So how do you solve something that has no x, just a squared term and a constant? Okay, so this is where we're looking at something like ax squared plus c. There is no bx. Okay. So what you do, step 1, isolate the square term by itself. So that means, if we had this ax squared plus c equals 0, we want the x squared by itself. So how would you do that? Well, you would subtract c and then divide by a. Okay, so we can solve for x squared just like we're solving for x. Okay. Then we take the square root of both sides. Okay. We did that before. And that's where we had x squared equals 5. So the reason we're square rooting both sides is the square and the squared are opposite operations. They will cancel each other out, giving you just what's inside your squared term. And then the other thing, but the big thing with the square root property is all the time people forget to do plus or minus. So that's the most common mistake. All right, so let's do some basic ones and maybe a little bit messier ones. So look at number 2. Let's start with that one. I do want to point out that we could factor this. This is a difference of squares. So that's x plus 10, x minus 10. Um, but let's do it with the square property. We can do the square property because there is no x term, just a square term and a constant. So what do we do first? Well, we're going to solve for x squared. We're going to isolate that x squared on both sides, or on one side. X squared equals 100. Then what do? We root both sides. Don't forget the plus or minus. So square root and squared cancel out. So we're left with x equal plus or minus. Well, what is the square root of 100? Well, that's just 10. But then you'd have two answers, x equals 10 and negative 10. If this was not a perfect square, like that square root of 50 we dealt with earlier, then you do have to simplify it as simplifying any radical. All right, let's back up to number 1. But the reason I'd like I'm not a big fan of square property because so many students forget the plus or minus, which is one reason you can factor, I like to factor, but just I repeat myself on that every single semester multiple times. People still get to the test and forget the plus or minus. All right, so let's solve this one. Now, can we factor this? X squared plus 4. Hopefully you're saying no, because this is a sum of squares, not a difference of squares. This is definitely not factorable. So this is either quadratic formula, or in this case, we can do square root property because there is no x. There's just a square term and a constant. What do? We're going to isolate the x squared. We get x squared equals negative 4. Then what do? Take square root of both sides. Get squared and squared cancel out. And this with x on the left. Hopefully you caught that I didn't put plus or minus. So here's the question. What is the square root of negative 4? Again, if you're putting your calculator, you should be getting an error. And why are we getting an error? Because we're taking the square root of a negative. And so you have to know that I is part of the answer. And then the square root of 4 is 2, so it'd be plus or minus 2i. Or in MATLAB, 2i, comma, negative 2i. So we're going to get imaginary numbers if you take the square root of a negative number. That's part of the answer. How about number 3? 25x squared minus 16 equal to 0. All right. So there is no x term here, but we can do the square root property. Square root property says isolate the squared term. Add 16 to both sides. 25x squared equals 16. Now, theoretically, you could take the square root of both sides right now, but then how do you deal with that square root of the number from the x squared? That can get messy. That's why you should always isolate your square term before you take the square root. Now we have x squared equals 16 over 25. Now we can take the square root of both sides because we have the x squared term by itself. Don't forget your plus or minus. X squared divided by, or x squared, square root and squared canceled out, leaving us x. We have plus or minus. Well, square root of 16 is 4, square root of 25 is 5, so it would be plus or minus 4/5. Or x equals 4/5, comma, negative 4/5. All right, so for basic square root property problems, it's pretty straightforward. Because you're basically just isolating your x squared term. Once you do that, then you take square root of both sides. Don't forget your plus or minus. And then you have a radical to simplify. There are more advanced versions of this. Let me just show you one of these. So number four, we have 3x plus 3 quantity squared equals 36. If I say solve that, what is your first instinct? Well, if you're thinking, well, we need to write 3x plus 3 out twice and FOIL it, that makes me happy because, in part, because that's something we talked about back when we were doing polynomials. However, if you do that, you're going to get a trinomial on this side. You're going to have a trinomial that's not equal to 0, so then you're going to have to subtract the 36 over, and then you're going to have to either factor or do quadratic formula, which you could do, but that makes it a lot of moving parts. And the more moving parts you have, the easier it is to make a little mistake here and there. So this is actually something we can do with the square root property. And no, we don't have an x squared, but notice we have something squared. All right. So you can think of that as like y squared. So the squared term is isolated by itself. So we can actually just start this problem by taking square root of both sides. So if I take the square root of both sides, yes, do plus or minus. So what happens on this left-hand side? How does this help us? Well, the square root and the squared cancel each other out. It does not matter what's inside the radical being squared. It's just these are opposite operations, so we're going to end up with that argument. So we're ending up with 3x plus 3. And then what do we get with the right-hand side? Well, square root of 36 is 6, so we get plus or minus 6. I don't know about you, but that seems like a lot fewer steps than like foiling it out, subtracting 36, and then going from there. But we're not done because we don't have x equals. So how do we get x equals when we have this plus or minus? Well, we need to, because of the plus or minus, we need to split this up into two problems. So 3x plus 3 equals positive 6, and then 3x plus 3 equals negative 6. So we split that up into two separate equations. From there, it's a normal solve process. We get x equals 1, and minus 3, I think. It's 3x equals negative 9, so yeah, 3, the x equals negative 3. So these quadratic equations, very often there's going to be, especially if they get a little messy, there's going to be more than one way to do them. And so that's why it's helpful for you to, as you go through the homework, do all these different techniques, because sometimes one's going to be more efficient than the other. And what's one, but that's all that can vary from person to person. All right, so that is the square root property. Square root property, most time is just going to have is applicable when you have an x squared and a constant with no x term. This is sort of a special case. We have a binomial squared, so that's something squared and a constant. And so that's the more advanced version of the square root property. All right. So how about the quadratic formula? The nice thing about the quadratic formula is it can solve any quadratic equation of degree 2. Doesn't matter how messy it is. It doesn't matter the answer is real or imaginary. Doesn't matter if it can be factored or not factored. Doesn't matter if we can use square property or not. Quadratic equation or quadratic formula can solve any quadratic equation. So the first thing you have to do, and don't skip this, please, is to set it equal to 0. So just like when you're solving by factoring, if you're solving by a quadratic equation, you got to make sure it's equal to 0. So if your equation is not equal to 0, that's going to make all your numbers useless because there's going to be a wrong sign in there at least. Now, one thing I will say, if you can see how to factor it right quick, then go ahead and factor it. That's going to bypass some work with quadratic formula. All right. So what is the quadratic formula? This is the only formula that you need for test one. So I don't think I'm gonna it's part of the test. I expect you, unless I say otherwise, assume that you have to have this memorized. I know in test two, there's a lot more formulas with like the lines and stuff. I'll give you those. But for quadratic formula, this is a pretty typical one, pretty powerful. So I expect you to know it. If you're an auditory learner, I have heard rumors that there's a song that goes to the tune of "Pop Goes the Weasel." That helps you memorize this. I've deliberately never learned it, so that way I can't be forced to sing it for you. But let me get you started. So negative b plus or minus square root b squared minus 4ac all over 2a. All right, you got to know this. And what are the a, the b, and the c? So the a, the b, and the c. Well, remember the generic quadratic equation that we're solving is, where's my line? Ax squared plus bx plus c. So a is the coefficient on the x squared, b is the coefficient on the x, c is the constant as long as it's equal to 0. So that's where the a, the b, and the c are coming from in the formula. Just general background. We'll talk more about this when we get into the test three, when we do parabolas at the beginning. When you have this, most of the time we're going to get two solutions because of the plus or minus. We expect that because we're solving a quadratic equation with x squared, we expect two answers. Now, if inside the radical is a positive number, then we're going to get two real answers because we're taking, the square root of a positive number is a real number. We're going to do plus or minus that number, two real answers. We could get one real answer that's repeated. So there are times where that goes to 0 inside the square root. So if you're doing plus or minus 0, you're getting the same answer. Just like before when we had that 5x minus 7 and 5x minus 7, we had the same x at the end. That's what's kind of happening here if inside is 0. What if inside is negative? If inside is negative, then we're going to get an imaginary answer, and we're still going to have two of them because of the plus or minus. If you ever see anything in the homework or in the notes that talk about the discriminant, the discriminant is what I just talked about. Like the discriminant is that b squared minus 4ac. It's talking about, is that a real number? Is it 0 or is it imaginary? All right. Well, let's jump into dealing with quadratic formula. So let's start with number 7. We have x squared minus 14x plus 45 equal to 0. Now that does factor, but let's assume that we don't see the factoring. And so what is step 1 if we're going to solve it with the quadratic formula? Step 1, that equal to 0. Which it is, so we're good. Step 2, identify your A, B, and C and plug them into the formula. Okay, so what is, especially if you haven't done this in a while, I think that it really helps to actually write them out, not just in your head. And so what is A for this equation? Remember, that's what we're solving. So A is the coefficient on x squared. So don't ever put x squareds or x's in your A and B. The A and B's are the coefficients. So A is 1, and it's 1x squared. B is negative 14, so don't lose those negatives. And then C is 45. All right, so now I'm going to go over to a different sheet of paper, and these can get kind of long. So now we're going to plug it into the form. The best way to memorize a formula is write down the base formula every single time you need it until you've got it memorized. This is what I do did as a student, and this is still, I think, the best advice I can give on how to memorize this. So write that down every single time. And so now what is to plug in your numbers? So negative b, now b was negative 14, so there is a double negative, so use parentheses. So plus or minus square root b squared, and again, b is negative, so use parentheses. If you don't use parentheses, you're going to get negative sign mistakes, and that's one of the most common mistakes in quadratic formulas with negative signs. Parentheses are important. Minus 4, a is 1 times c, which is 45, all over 2 times a, which a is 1. So there is step 2, plug it in, get your a, b, and c, plug them in. So step 3 is simplify. A lot of mistakes that can be made here. Now, in terms of calculator usage, um, I know sometimes people are taught to just like put the whole thing in the calculator at once, um, which can potentially work. I don't know how you're doing the plus or minus. Maybe you're just thinking it was plus and knowing it's plus or minus. But if that's a negative number inside the radical and you're going to get an imaginary answer, you plug this all in the calculator, it's going to pop out, a domain error. So here's what I want you to do with the calculator is don't do it all at once. Do it use your calculator for the steps. And here we have a double negative, so that's 14. And so like doing this in the calculator is acceptable. So like do inside the radical on. But again, make sure that you put those parentheses, right? Because there's a big difference between negative 14. There's a big difference between negative 14 squared, which is negative 196, versus negative 14 in parentheses squared, which is what we're supposed to have, which is a positive 196. Got to have those parentheses when you're squaring it. Some people like to do it all at once in the calculator. I'm still kind of old school, so. So inside we get 196 minus 180, and then we simplify it at 14 plus or minus 196 minus 180 is 16 over 2. So now step 4, once you get down to here, is simplify your radical. Once you get it down to a single number, simplify that. Okay? Which in this case, square root of 16 is 4. So we get 14 plus or minus 4 over 2. Step 5 is simplify what's left over. Simplify the rest. Now, if there is a whole number, if the radical turned out to a whole number, here's what you need to do, is you need to split this up into 2 answers with a plus or minus. It'd be 14 plus 4 over 2, and x equals 14 minus 4 over 2. If you have a I or a radical left over, then splitting up the plus or minus simplified doesn't help, and we'll do examples like that. All right. Now, if you do get whole numbers or fractions, that does tell you that the original problem actually factored. And so some of you may have looked at that x squared minus 14x plus 45 and saw how to factor it, and you could have got to hear it a little bit quicker. That's the nice thing about the quadratic formula is it will solve any quadratic equation. All right. So we were solving x squared, number 8 is x squared minus 4x equals 0. Okay. So another one equal to 0. So step 1 is done. Step 1, 0, done. So now, step 2, what is your A, your B, and your C? Well, A is 1 because we have 1x squared. What is B and what is C? Well, one of them is -4. Is that B or is it C? Well, the -4 is with the X, and there is no constant, so C is going to be 0. So when you're doing the quadratic formula, we will occasionally get B or C equal to 0. So if there's no constant, C is 0. If we were doing this x squared minus 4, there is no x term, so then B would be 0. So it does happen where sometimes B or C is equal to 0. A would never be equal to 0 because if you don't have a square term, then you don't have then you don't have degree 2, then it's a linear equation. But B or C might be equal to 0. So just for emphasis, I'm going to write down the generic quadratic formula again. Again, I can't emphasize enough how helpful it is to write that down every single time until you get it memorized. So now we plug it in. We got -B, so that's a double negative. You can think of that as opposite of B, if that helps. So if B starts negative, it goes to positive, or vice versa in that first term. And then B squared is parentheses, -4 squared, -4 times 1 times 0 over 2 times 1. Now we simplify that. We get 4 plus or minus, so that's 16. Well, that goes to 0. And then we can square. So we're getting 4 plus or minus square root of 16 over 2. Now we simplify the radical. Square root of 16 is 4. So again, we have a whole number. And so now we split this up into two parts. X equals 4 plus 4 over 2, and x equals 4 minus 4 over 2. We get 8 over 2, which is 4, and 0 over 2, which is 0. Which if you had factored this, that would have factored to x, because there's a GCF, and x minus 4 equals 0. Well, x equals 0, that x by itself, that's x equals 0, and x minus 4 equals 0, because x equals positive 4. So if you had seen how to factor that in with the GCF, you could have skipped the whole quadratic form. But it's not always that easy. All right. Let's do number 12. We have x squared minus 4x minus 13 equal to 0. Now, if you try to factor this, you're going to waste a lot of time because with the 1 in front of the x squared, we're looking for what multiplies to give me 13. It's going to abstract to give me 4. This is not going to factor. That's why I say take a little bit of time, see if you can factor. If not, go to the quadratic formula. It's already equal to 0. So get your A, your B, and your C. So A is 1, B is -4, C is -13. Now we're going to plug that into our quadratic formula and see what happens. So we got -B, so we got, again, we have a double negative. It's just, I kind of randomly picking examples here, so that's not always going to be a positive number up front. It's just each time so far we've had a -B. 4 times A times C over 2 times A, 2 times 1. Wait, 4 plus or minus -4 squared is 16. Here's where a lot of mistakes are going to be made on this one. If you get, what is 4 times 52? Yeah, if you say -52, then you are going to get a negative result. You're going to have an imaginary answer. But that's going to be wrong, not because the imaginary issue is wrong. It's because what's a negative times a negative? So watch out for that. A lot of times when C is negative, people tend to lose that. But that will be plus 52. All right, so x equals 4 plus or minus, what is that, 58, 68 over 2. Okay, and so now 68 is not a perfect square. Because 7 squared is 49, 8 squared is 64, 9 squared is 81. So if you don't have the nice little scientific calculator, again, you're going to have to do your factor tree. So if you do have a graphic calculator, you may want to like find a scientific calculator to borrow just for like the quadratic formula stuff. Yeah. So square root of 68 is 2 square root of 17. And where that comes from is if you divide that by 2, so you can, if you do your factor tree, we know it's even, so we can divide by 2. Divide that by 2, we get 34. And then 34 is even, so we can divide by 2 again, and we get 17. So we have two 2's, which is why 1 2 is on the outside, and then we have 117. So that's where that's coming from. You're doing that by hand. So a lot of mistakes would have been made up here on this, and a lot of mistakes are going to be made here at this point, because how do you simplify this? If you're wanting to divide just those 2's, that's bad. Want to divide the 4 by 2, that's also bad. Remember, at this stage, this last stage, you need a GCF in all 3. If there's not a GCF in all 3, you're done. If there is, then divide each one by the GCF. So there is a GCF of 2. So we're going to divide all 3 of those numbers by 2. We get 2 plus or minus 1 square root of 17 over 1. But anytime we something over 1, that's a whole number. And we don't really need the 1 in front of this, just like we don't need a 1x in the final answer. It'd be 2 plus or minus square root of 17. Or in math lab, 2 plus square root of 17 to minus square root of 17. So when you're simplifying your quadratic formula, if you have a radical left over, it doesn't do you any good at the beginning, really, to kind of split it up. I mean, I guess it doesn't do any good. If you want to do that, actually, for some of you, that may help with the simplifying. If we did split it up, it'd be the 4 over 2 and plus or minus the 2 squared 17 over 2. Then the 2's cancel, means square 17, and then 4 divided by 2 is 2. The reason I say it doesn't help is most people, I think it's easier to see the GCF in all 3, but if this helps, then by all means, do it that way. All right, so there is an example of 2 real solutions. Let's see. The problem is I didn't type out my answers. And so I'm trying to find one that has. Let me go back in and check the answer right quick. I'll see if I can get one that has imaginary results. That's what I didn't print off all my pages. All right, let's see. It's 15. All right. So this one is in the handout, but I didn't print it off. Let's look at number 17 in the handout. So we're solving, what is it? 4x squared plus 1 equals 3x. It's a quadratic equation because it's x squared. So we can't, and there is an x squared and an x. So we can't do the square root property. So that means we're either solving by factoring or solving by quadratic formula. And for both of those, what is the first step? The first step, it has to be equal to 0. And again, I want my square term to be positive, so I'm going to move 3x over. And then make sure to, put it in descending order. keep like terms with like terms, all that. We have 4x squared minus 3x plus 1 equal to 0. Okay. Does that factor? Yeah, this is yeah, 1 is 1 and 1. It might factor because what multiplies to give us 4. That's going to subtract, might do a 4. So you might want to play around with it, but if you play around with it for a little bit, this one's not going to factor, right? So there is no guarantee that they'll factor, and don't waste too much time trying to factor, because if it doesn't factor or you can't see how to factor it, always go to the quadratic form. So what is our A, our B, and our C? So now we have A is 4 instead of 1. So I have a negative B. Again, that's just coincidence. So just happen to pick all these examples where B is negative. So now we plug that in, get a negative, opposite -3, so double negative there. And then -3 squared in parentheses minus 4 times A, which is 4, times C, which is 1, all over 2 times A, which is 2 times 4. Now we simplify that. +3 plus or minus -3 squared is 9, minus 16 over 8. That simplifies down to 3 plus or minus square root of -7 over 8. All right. So again, I'd really like to be able to pause and ask if there's any questions here, but I guess if there is, you kind of back up and see what happened, or again, always email me. So we know once we did that simplifying, now we need to simplify that square root. So how do we simplify a square root of -7? Well, if that was a +7, then there would be nothing to simplify because square root of 7 is square root of 7. It's a decimal. It's a prime number. There's nothing you can do with that. So had that been no negative, this would have just been 3 plus or minus square root of 7 over 8. But because there's a negative, there has to be an I in the answer. The plus or minus, I put the I in front of the radical. And then are we done? Well, is there a GCF? Well, there's nothing that goes into 3 and 1 and 8. So this is actually simplified measurable. So we can either have that as an answer, or in MATLAB, we have to do 3 plus I squared root of 7 over 8, comma, 3 minus I squared root of 7 over 8. So we can get, if you get a negative inside that square root, doesn't guarantee you did anything wrong. It just means that as long as everything else is correct, you're going to have an I as part of the solution. You take that negative outside the square root and then simplify that. If you put that in a calculator, it's going to, square root of 7 is going to equal square root of 7. That's telling you that it is simplified. Okay, this is solving quadratic equations. So our generic, just to recap, our generic equation, quadratic equation is ax squared plus bx plus c equal to 0. They don't have to be x's, they can be any variable, but the important thing is it's degree 2. So for solving a degree 2 polynomial, then we either have solved by factoring, square root property, or the quadratic formula. Square root property is most useful if there's no x term, just a square term and a constant. Right? So make sure you can follow that. The solve by factoring and the quadratic formula both need to be equal to 0 before you do the factoring and the quadratic formula. And then if you can factor it, factor it. If you can't see how to factor it fairly quickly, do your quadratic formula. Which again, I do expect you to have this memorized. You're in college algebra. It's the only formula for this test. So I'll use that in graduate level math classes. It's a pretty powerful formula. All right. Is there anything in math lab? So if you go to math lab, now there's only 13 questions. However, these are a little bit longer. And so even this is not necessarily a short homework assignment because these problems do take longer. Like the roots and radicals, a lot of those were short questions, so there were more, and there was like a variety of them. Here, there's three techniques you're using. Prac- definitely practice the factoring and the quadratic formula, the square property. If you if you're struggling with that, it can save you time in special instances. But again, you can always kind of go back to the quadratic formula if all else fails. But they're all techniques for solving quadratic equations, like this one. Oh, was it sharing? It would help if I shared it, right? Let's see. Sharing the row. Yeah. So x squared equals 169. Okay. That is about as straightforward as you can get with the square. And it even says in the instructions, use the square root method. They're trying to give you a hint there. So get in the habit of reading the instructions, right? So that's already isolated. You just take the square root of both sides. Don't forget your plus or minus. You're done. If you wanted to solve this by a quadratic formula, you'd have to move the 169 over, and then A would be 1, B would be 0 because there is no x term, and then C would be negative 169 because you've now subtracted it over. So, like I said, this is the special case. Again, they're saying square root method, so they're trying to give you a hint. You just take the square root of both sides, and that left-hand side becomes x minus 2. You could write it out twice and FOIL it out, and then subtract the 9 over, make it equal 0, and do quadratic formula. That's the longer way to do it, but that would also work. And then the rest of them, now it is just basically you get a lot of practice at the end on your quadratic formula. And really to me, quadratic formula, at least at the level we're doing at, it's not so much an algebra problem as it is, I mean, it is algebra because we're solving, but it's really about arithmetic. Like, can you plug the numbers in, deal with all your negative signs? Can you simplify square roots? Can you simplify, that answer at the end where you have like the three pieces? So that's where almost all the mistakes are made with quadratic formula is in the simplifying process. Sometimes people forget to set it equal to 0. And then if you do that, like your A, your B, or your C will be wrong. But the vast majority of the issues with quadratic formula is really in the simplifying part. I noticed on some of these, I'm curious, but in the answer I noticed on 11, solution's not a real number. Um, but they say up here, find the real solutions. All right, so that's telling me that you're going to get a real answer. I kind of wish they were all where they just said, here's, what's the answer? But right. So when it comes to unit one, um, there are, to me, there are three big topics. One, can you factor? Two, can you solve linear equations? Which linear equation kind of bleeds into formulas and inequalities, but can you solve linear equations? And three, can you solve quadratic equations? All right, so this 1, 2, 1, 3 homework is definitely going to be featured highly on the test. So if you have any questions on this, make sure to ask sooner rather than later. But for today, that's all I have. And so have a good one.